Okay, now we're going to talk about completing the square. First, I'm going to give an example where they give us a polynomial, but we need to find this last term. In other words, we need to make this polynomial a perfect square. What we need to do is take half of b and then square the result. All right, these are the steps to making a perfect square trinomial. You take half of your b and you square the result. So I have here as my a 1, I have my b is negative a half, and my c is not determined yet, and I'm going to determine that by taking half of the b and then squaring the result. So I'm going to take half of b. Half of 1/2 is 1/4, but let's prove it. So to take half of 1/2, I multiply 1/2 by a half, because a half simply means multiply by a half. And so then I'm going to square whatever that is. So I'm going to go ahead and do that right there. Inside here would be multiply the numerators, then multiply their denominators. So my c would be 1/4 squared, and 1/4 squared is, well, that's 1 squared is 1, and then 4 squared is 16. So the value of c would be 16. So as a perfect square trinomial, this should be rewritten as x squared minus 1/2 x plus 1/16. And that's what I'm looking for right there. Okay, let's look at another problem. Let's look at how to solve these quadratics using complete the square method. So what I'm going to do, the first thing I'm going to do is realize that this is not a perfect square the way it is. And we can test that by saying negative 21 is not a perfect square. First of all, to have a perfect square, your c cannot be negative. So what I'm going to do is move this c out of there. I don't want it there anymore because it's not a perfect square. So to move this out of here, I'm going to add 21 to both sides. And let's draw my line for addition here. And I'm going to have v squared plus 10v. I'm going to leave a little space right here because I'm going to do something with that. Equals 25. And I'm going to put a little space afterwards, and I'll show you what I'm going to do. So now I want to make this left-hand side a perfect square trinomial. Remember, the rule is take half of your b is 10, half of 10 is 5, and square the result. And so that's really going to be 5 squared. And so my new c is going to be 25. So this c in there is going to be 25. Now that's a perfect square trinomial, but keep in mind I have to use the addition property of equality, which states that if I'm going to add something on one side, to keep this thing equal, I need to add the same thing on the other side. So since I added 25, this 25 came out of nowhere. I put it there because I wanted to make a square. So now I need to make sure I add 25 on the other side too, because I added 25 right here. I need to do the same thing on the other side as I did on this side. Now, going from this is a perfect square trinomial. It can be rewritten as v plus 5 squared. How do I know that? The square root of v squared is v, square root of 25 is 5. And the positive sign here comes down. Boom. 25 plus 25 is 50. Now, I'm just going to rewrite this here. To get rid of a square, because I need to solve for v, to get rid of a square, I take the square root. It's the inverse operation of squaring. Then I know I'm going to have v plus 5, because this square root cancels out that square, equals plus or minus the square root of 50. But I'm going to rewrite the square root of 50 as 25 times 2. And so what I'm going to have now is v plus 5 equals plus or minus the square root of 25 is 5. And the square root of 2 is still in there. I'm going to move this up. I'm going to subtract 5 on both sides so I can solve for v. So then v is essentially going to equal a negative 5 plus or minus 5 radical 2. And that's my complete answer. And you can go on with that, find out what radical 2 is, and then add negative 5 to whatever's on the right-hand side, and then subtract take negative 5 and then subtract whatever 5 radical 2 is. You can do that as well. Or you can leave it in this form, which is absolutely fine. Finish all those problems on that page, and have a great day.